Hi everyone, this is Mr. Tate. I'm just going to go ahead and go through these notes for the makeup assignment. A few of the announcements that we talked about today in class is that we are on week 6. Next week we are doing the next progress check. Some of you guys are not doing very well on that, and it's kind of a correlation, a direct correlation to not spending enough time or not spending quality time working on MobiMax. Secondly, if you did not take the alternate assignment that we had last week, since there was no class, it was a 25 question, one step equations that you were solving for a quiz, and that was to be done in the testing center. So you have until tomorrow, May 9th, to still make that up and not lose half points. But if you do it after, you can still do it. I would recommend that you take it as soon as possible. Starting here, a lot of this should look familiar, so I will go through nonetheless. All right, so to start, let's review some one-step equations. So remember, the goal of solving an equation is to find the value of the variable. Okay, and we do this by isolating the variable on one side of the equation, or the equal sign, by using inverse operations. Excuse me. All right, so some review, and we only really talked about 4 of these operations, and there are a few other ones, or at least a couple other ones that we would talk about normally, but these are the most common and some of the more basic ones. Starting with addition, when we have that operation, the opposite would be subtraction. And therefore, the opposite of subtraction would be addition. So keep in mind, so addition and subtraction, they are kind of like partners, okay? But they undo each other. Then the next 2 are multiplication and division, and these 2 are the inverses of each other. They're the partners that go along. So the opposite of multiplication then would be division. And then the opposite of division would be multiplication. Okay? We had examples of all 4 of these, and we'll go through these. I don't remember if they're the same or if they're slightly different. In this case, looking at the variable, the one thing that's going on is we are adding 3. Okay, so since I'm adding 3 to both sides, I'm adding 3, and I want to get this x all by itself, I need to do the opposite of adding 3, which is subtract 3, and then subtract 3 over here. 3 minus 3, that cancels. This x just remains down below. And then I've got 13 minus 3, leaving me with a 10. Now, something to keep in mind, and when we get into the next part, we want to make sure that our equations are simplified on the left and simplified on the right before we start solving. We don't have anything worrying or anything to worry about for simplifying here except for the actual solving part. Let's take a look at the next one. 8 minus 6 equals 18. My variable is a, and I need to get that by itself. All right, right now we are subtracting 6. Therefore, I need to add 6 to both sides. All right, negative 6 plus 6, that will be 0. Okay, so I don't really need that. The a just falls to the next line. 18 plus 6 is 24. And now I want to review a few things here. When I'm working with this 13 minus 3, if, for example, 13 minus 3 might be simple enough to do in your head, but a little bit of review on adding and subtracting terms together. So I always will write the bigger number on top. So 13 and 3. Even though I know one of these is negative, okay, the sign in front of the 13 would be a positive 13. since they're different, we would want to subtract. Okay, then I have 13 minus 3, and of course we got 10. Now I want to make sure if it's positive or if it's actually negative, and the way we tell that is by looking at the two things we were adding and subtracting and determining which was the bigger number. So hopefully you guys agree that 13 is bigger than 3, and the sign that was on the 13 was positive. So indeed, the 10 was positive. I could put a little plus sign there. It's not necessary. And that's why we ended up with the 17. Over here, when I'm doing 18 plus 6, probably you guys can do that in your head. But I could break it down the same way. And technically, it's already broken down the way we would over on the side. But I'm combining 18 and 6. The bigger number is 18. The smaller number is 6. Since they are the same sign, I add them. And then 8 plus 6 is 14. 1 plus 1 is 2, and we get a 24. Okay? Let's check out the next ones over here. 9y is equal to 36. The really important takeaway, or something that you should know, that 9y is the same thing as saying 9 times y, and we know times is a multiplication operation. If I wanted to squeeze in a symbol to represent multiplication, a lot of times we just put a little dot there because the multiplication dot is another symbol we use for multiplication. We are multiplying the y by 9, so I want to divide by 9, and I use this fraction bar because that's how we usually denote division in algebra. 9 divided by 9, I've got the y left over, so I have the y is equal to whatever 36 divided by 9 is, which is 4. Moving on to the last one over here. Z fifths, or z over 5, is equal to 8. Keep in mind, this means divide. This right here, this expression, is the same thing as saying z divided by 5. So to undo that, we want to say z times 5, and I could use parentheses to denote that. So I want to multiply this by 5 and multiply this by 5. In class, we mentioned that we could make this 5 over 1 if it's easier to think about. These 5s, they reduce each other, and a lot of times you hear them say they cancel each other out, okay? And then I have just the z, and I would have z over 1, but z over 1 is the same thing as just z. 8 times 5 is 40, and that would be my answer. Alright, so let's talk about this part over here. Solving multi-step equations. A multi-step equation is an equation that requires more than one different mathematical operation to solve. Let me double check that's what Ms. Cook wanted us for that spot. Yeah. Okay. In other words, there's more than one thing being done to the variable. Alright, so let's talk about how we simplify. Starting with this example right here. The 4, in the parentheses I've got x plus 2. 4 times the quantity of x plus 2 minus 3 is equal to 25. Now the first thing I want to check is that we actually have a simplified expression. We want to make sure that we simplify both sides of the equations. This means combining any like terms. And or using the distributive property. Remember, distributive property, let me finish writing this. The distributive property actually shows up in this example right here, where there's the 4 on the outside of these parentheses. And remember, that means we are going to multiply. Okay, so looking over here, we're not simplified yet. So I'm going to have to rewrite the problem anyways. Okay, let me go ahead and distribute. So keep in mind I'm multiplying the 4 times the x and the 4 times the 2. So I get a 4x plus 8 minus 3 equals 25. If you need a little bit of review on distributive property, come on in. And sometimes when we first introduce this, we kind of break it up into another extra step in between. But at that point, there's nothing distributive property wise to do. I'm going to check if there's any like terms. And I notice that I've got, let me looking over here, this is one possible kind of term where there's a variable of x. Now the next two do not have x's in them. So this is, maybe I should pick a color not as close to purple. This is 1. Okay, and keep in mind the signs in front are attached to the number behind it. Okay, if I'm looking at the 4x, if I wanted to think about what sign it would be, if there's no sign that's visible, we could always put a little plus in front. The next one here is a -3 or -3. Now over on the right, there's nothing to combine, and then we will move stuff from left to right or vice versa in different problems. But in this case, I'm just simplifying, and then I will get into the moving to the left or to the right. Now I want to combine these two. Okay. The 4x, the positive 4x is okay. I can leave it alone. I've got an 8 and I've got a -3. And if I'm kind of doing some of that math on my head over here, 8, 3 on the bottom. This is a +8, this is a minus, so because they're different, I subtract, get a 5, but the 8 was positive, and that's the bigger number, so it's going to stay positive. Positive 5 equals 25. So here we are simplified, and if I'm going through, I'm like, okay, I've checked that off. Now I can look at the first operation to undo, and then the second operation if necessary. So next we use our inverse operations to solve or isolate the variable. Since we have more than one operation, we must go in reverse order. All right, so remember when we are using this, you guys are very familiar with PEMDAS, but we only use PEMDAS when we are trying to simplify. Okay? When we are solving for the variable, that's when we use this reverse order of, let me see here, solving. When we use ACETM, okay, and then just kind of notice that we ended with the S, we start with the S. But also something to notice, or to keep in mind, when we're solving, we're looking for anything that is adding or subtracting. Next, we look for anything that is dividing or multiplying, and then we move on from there. But we will not cover those last two today. So to undo, let's see, to undo addition or subtraction. Oh, we want to undo anything that involves addition or subtraction first, and that's kind of like we underline this one here. Then we do anything with multiplication or division. And then we would move on, like we said, to exponents and parentheses, but we're not going to be covering that today. Now remember, whatever inverse operation does to one side, we must do the same to the other side. And then we want to finish with an isolated variable. That means a 1x or a 1y or whatever variable it is by itself. So let's go ahead and look over here. Now that I'm simplified, I can think about the operation. Okay, now if I'm going backwards, I have to do anything subtraction or addition. I notice that I've got an add 5 here. So I want to do the opposite of add 5, which is subtract 5. And I'll just go ahead and do that first. -5, -5. These would reduce or cancel to 0. And then my 4x still there. 20 minus 5 is equal to 20. If you guys need to do something like that, you can. The second operation, and this is super important, 4x is the same thing as 4 times x. So we are multiplying x. So however you want to put like a multiplication dot or maybe just the x, that's fine. The opposite is divide by 4. So I'm going to divide by 4 on both. And I get x is equal to 20 divided by 4, which is 5. All right. Okay, so that's my final answer for this problem. Now, I do want to think about all of those things down below. In class, we had students write out every single part. A couple things, and won't show up on your copy version because you'll be doing it online instead. I at least want to do a couple of the problems together, starting with number 12. Okay, is it simplified? Not yet. Okay, one of the reasons why I know it's not simplified is I've got this distributive property operation going on. Okay, so I'm going to take care of that. After that, I want to make sure there's no like terms to combine. So let's go ahead and simplify that real quick. Let me rewrite this. 20 is equal to 2 times 3x plus 5 minus x. If I distribute that, I'm going to multiply the 2 times the 3x and the 2 times the positive 5. So 2 times, let me rewrite some of this. 20 equals 2 times 3x is 6x, and then 2 times positive 5 is a positive 10. Still have the minus x, so keep in mind I didn't change anything with that, so it's still there. Now looking at it, left side still okay, right side I've got something I can combine. That being my 6x and my negative x. Okay, so keep in mind, there is no number written in front of that negative x, but if I wanted to, I could squeeze in a 1 there, and that would be negative 1x. There is no sign in front of the 6x, but I could put a plus there. Alright, so I've got a plus 6 and a negative 1. We can do our side math. However, 6 minus 1, hopefully it's not too hard to think about, 5x. The plus 10 is still there. And then now my equation is simplified and ready to start solving. So now that I'm simplified, first thing I would check for is any adding or subtracting. I notice that I've got a plus 10 there, so I want to subtract 10. Let me do that. 10s are gone. 5x still there, so it's still right there on the right. 10 minus 20 is 10. Next thing, remember 5x means we are going to multiply x by 5. So I want to divide both sides by 5. Okay, so reduce x on the right, and then 10 divided by 5 is 2. I'm going to do one more of these problems for you here. Looking at 7 minus a. Is it simplified? We can take a look and notice that it is simplified. Over on the left, there's nothing that would be like the same type of category, or when we get into Algebra 1, we'll know them as terms. And obviously on the right, if there's only one thing, there's nothing to combine there. So it is simplified. Now it's helpful to do a couple things. There's no sign that shows up in front of the 7, but if I need to, I could put a plus 7. And there's no number in front of the a, just a minus, but I could put a negative 1a. Okay, remember we're always doing adding or subtracting first, so we need to notice that this is a plus 7. So I have a plus 7, opposite of plus 7 is to subtract 7. Alright, so let me rewrite this problem real quick. 7 minus, if I want to, I could put these signs in here if that's helpful. We did say that we need to do the opposite of add 7, which is subtract 7. those 7's are gone. This negative 1a is still there. And then 28 minus 7 is going to be 21. Now, me putting in the negative 1 before the a, when there was just the negative sign, is helpful because I realized that I am multiplying a negative 1. So I need to divide by negative 1. So I'm going to divide this and divide that by negative 1 and negative 1. These are gone, and I've got just the a that remains on the left, and 21 divided by negative 1 is negative 21. Okay, that's it. I'll leave the problems for you to solve on the quiz.